Hello! In the previous video, we looked at the 1 to 4 split operation in a triangular mesh. In this video, we show another split operation called the square root 3 subdivision. We will do a step-by-step demonstration of the algorithm using a simple mesh consisting of a single triangle initially. The algorithm works by first finding the barycenter of each triangle face in the mesh, as shown here in the bottom. Then we connect the barycenter of each face to the corresponding vertices, like this. Finally, we flip the old edges to get a regular pattern. The result is that after one full pass of the algorithm, each original face gets split into 3 smaller triangles. I will first show a simplified version of the algorithm that does not flip the edges. It simply finds the barycenter at each pass and connects them to the vertices. Then we will see what problems arise and why we need to do the edge flipping step. Let's do one step. Here is the barycenter connected to the vertices. Let's do a few more steps and watch it find the barycenter of the new triangles. As you can see, there is a problem with what we're doing. The number of edges on some vertices, such as near the corners and in the center, is growing without bound, and the faces in that region are using triangles that have smaller and smaller angles. This causes numerical approximation problems, since you need more and more precision to determine to which face a point in one of these regions belongs to, as the number of iterations grow. The second version of the algorithm solves that problem by implementing the edge flipping. Now every full application of the algorithm will correspond to 2 steps in our demonstration. First, we find the barycenter and connect it. Now there's nothing to flip here because all faces are on the boundary. So let's do one more pass. We will find the barycenters and now we will flip the faces. For example, this face will flip into here, and this face will go here, and this face will go here. And as a result, we will have a nice triangular region here in the center. There you go. Let's do a few more iterations. As you can see, a new problem emerges with what we're doing. Although in the center a regular pattern emerges, near the boundaries we have these thinner and thinner triangles with smaller and smaller angles, leading to the same problems as before on the boundary. The way to solve it is to apply a special rule to the faces on the boundary. We will do a third example where on one pass, corresponding to 2 steps, we will split everything as usual. On the second pass, we will, instead of splitting the faces on the center, for the faces that are on the boundary, we will flip them at the edges in 3 ways. Let's do a few passes. So first, we find the barycenter, and as usual, there's nothing to flip here. Next pass, instead of adding a point here to these barycenters, we will add 2 points to each outer edge and connect them to the center. Now we finally flip them. The result is a very regular pattern where the original triangle was split into 9 smaller triangles. If we do a few more passes, we will see that every 4 steps the same regular pattern emerges. So here we find the barycenters, we flip. Now we do the special case on the edges, splitting each edge into 3 for edges on the boundary. And after flipping, we get the same regular pattern. 1, 2, 3, 4, and the pattern emerges again. In the next video, we will add to this topological split operation a geometric smoothing rule. This will allow us to make the original figure smoother at every step. Thanks for watching.